Welcome back to the second session in the series of 5 pre-recorded training sessions focusing on the application of the mitigation hierarchy, particularly in the context of EIA. In this second session, the focus will be on the intersection or the relationship between the mitigation hierarchy and the assessment of significance. I'll begin by considering the relevance of the mitigation hierarchy throughout the EIA process. Then look at the relationship between the mitigation hierarchy and impact significance, and then finally, how the mitigation hierarchy affects the determination of impact significance. Just to acknowledge before we begin that the topic of impact significance in the context of EIA is a complex one. We appreciate that there are different opinions about how one should go about determining impact significance and where the emphasis should be between social, biophysical, and economic types of impact. Whilst this training draws on common practice in South Africa, we do appreciate that debate about impact significance is evolving, and the debate about how to approach impact significance are ongoing not only in South Africa, but also globally. So just a reminder of what the model of the mitigation hierarchy looks like. In this depiction, I have again distinguished the preventative from the remediative components of the model. And as the triangular shapes reflects, again, prevention is the preferred approach to ensuring minimal damage to biodiversity. The implication is that site selection and early intervention at the pre-planning phase is important for avoiding potential fatal flaws, and that residual impacts are more difficult and expensive to address in later stages of project development. So this simple flow diagram of key stages in the EIA process depicts the relevance of the mitigation hierarchy throughout the process. The model of the mitigation hierarchy, therefore, offers us a way of thinking about impacts that ought to permeate the entire process, from the beginning stages of defining the project area of influence, through screening and the consideration of alternatives, assessing different types of impacts, and then identifying ways to prevent impacts. Unavoidable impacts must be assessed in terms of potential for rehabilitation and/or restoration. Careful consideration must be given to the feasibility of proposed mitigation measures and impact management outcomes. And then finally, any residual impacts must be identified and assessed to determine if and how compensation can be achieved. And then particularly important is to ensure that direct and indirect as well as cumulative impacts are assessed and that the mitigation measures are given effect in the EMPR. So this figure is in the draft mitigation hierarchy guideline, and I won't take the time to go through it in detail, but it's worthwhile studying it as it shows the phases of a typical environmental assessment: the pre-application phase, the assessment itself, and then the post-authorization phase. The key activities that take place are identified and important considerations are highlighted, and these then relate to what ought to be achieved in terms of the mitigation hierarchy. As all South African practitioners would be aware, we have a two-tiered approach to environmental assessment in this country, governed by specific timeframes, generally 90 days for the basic assessment and 150 days for a full scoping in EIR. Whilst this obviously has implications for the practical arrangements and timing of key activities, the basic philosophy and intent of the mitigation hierarchy should apply to either type of assessment. There is a presumption in this two-tier arrangement that some types of activities are inherently less risky or damaging. But as we should all be aware, the location and sensitivity of the receiving environment is key when it comes to determining impact significance, as a relatively small development in a sensitive area can be as impactful as a large development in a less sensitive environment. So what is stressed in the mitigation hierarchy guideline is the need to consider and plan for the implementation of mitigation measures as early as possible, and certainly prior to submitting a formal application. Whether or not the mitigation measures are applied in the context of the basic or the full assessment all types of mitigation will come with time and cost implications, which from a practical perspective need to be explained to the project proponent as early as possible to allow for adequate planning, and then, if necessary, for consideration of avoidance or lower impact alternatives. So in this early pre-planning phase, it's particularly important that firstly there be early identification of fatal flaws when there are no options for preventing either the irreversible or the irreplaceable loss of biodiversity and ecological infrastructure. And then secondly, there needs to be a recognition of the likelihood of residual impacts, which will prompt the requirement for a possible biodiversity offset. And as I have stressed here, the manifestation of either of these should not come as a surprise to the project proponent or be up to a commenting authority or interested and affected stakeholder to point out only once the formal application has already been submitted. So the draft mitigation hierarchy guideline includes definitions for fatal flaw and residual impact, which I have presented on the slide, and these definitions are the same as those in the biodiversity offset guideline. So a fatal flaw is a major defect or deficiency in a project proposal that should result in environmental authorization being refused. So from a biodiversity perspective, the associated residual negative impact would have a very high significance. And this would be the case where the project would result in irreplaceable loss to biodiversity or ecological infrastructure or any other unique or indispensable resource. So there are several tools available that help point to the potential or likelihood of a fatal flaw in the initial stages of project planning. So these would include the screening tool, associated protocols and guidelines, things like bioregional maps and other spatial and conservation planning databases that would form the basis of EMFs, spatial development frameworks, IDPs, etc. And then, finally and importantly, the public reaction or response to a proposal could also be an important indicator of a potential fatal flaw. So whilst the identification of a fatal flaw should come as early as possible in the process, the determination of residual impacts follows on from the application of prior stages in the mitigation hierarchy, including avoidance, minimization, and rehabilitation. And only then can the existence of a residual impact justify the need for compensation or biodiversity offset. So what's important is that the EAP communicate early, explicitly, and honestly to proponents about the potential for fatal flaws or the likelihood of post-mitigation residual impacts. It's in nobody's interest, and certainly not in the interest of environmental protection, to identify problems but then argue that a client or a proponent still has the right to go through the process towards authorization. This argument doesn't make sense in the professional context of EIA. So on the subject of professionalism, so since the establishment of EPASA, which is the Environmental Assessment Practitioners Association, there is now a distinct code or set of rules which effectively makes EIA or EAPS comparable to other professionals. In this regard, we need to consider the meaning of professionalism and what it dictates in terms of communication and behaviors. For example, a healthcare professional would not prescribe a treatment for a patient that would be ineffective, and similarly, an engineer or architect would not proceed with the design of an unworkable solution, even if their client may disagree or want something cheaper. Mitigation should also not be up for negotiation when guidelines or specialist studies and site inspections and so forth indicate that mitigation is a requirement. So the onus on the EAP is to prioritize the commitment to the environment over and above the interests of their clients, and this means providing emphatic and expert advice about, firstly, whether it is advisable to proceed, how and when one can proceed, and what the risks are. And if these risks are too high, the EAP must spell that out and advise their client accordingly. Just like an auditor would be obligated to raise a red flag if a client's books don't balance, the EAPs are under a similar obligation in their work to ensure that they don't end up bearing responsibility for environmental transgressions or damage that could occur as a consequence of irresponsible and harmful development activities. So the cornerstone of successful and effective application of the mitigation hierarchy is the issue of impact significance and how significance is determined through a combination of assessment and evaluation. So this slide depicts what ought to be familiar, the relationship between assessment component of the EIA and the evaluation component. So the assessment focuses on the scientific process of collecting, analyzing, and communicating information, and then evaluation focuses on what impacts mean for people and communities, which we all understand to be the more complex component of EIAs. Suffice to say that there are different approaches and methods for both of these aspects, and it is inevitably a combination of science and wisdom, for want of a better word, that supports the most effective solutions. And as we have seen, more and more of late, is that the communities that are affected by potentially negative outcomes are adopting emphatic positions about the potential harmful impacts of development, and this is a reminder to be wary of presuming that monetary value or economic benefits that may accrue as a result of development necessarily outweigh the value to communities of natural amenities, of ecological infrastructure, and the importance of heritage or spiritual connections with natural resources. So whilst there are a number of ways to assess significance, there are some guidelines or rules that ought to feature irrespective of the method elected. So first, obviously, to accept that impact assessment is not a pure science, but there are plenty of tools and databases and policies and guidelines that can increase the objective measure of impacts. And then the second cautionary on the slide is that you should avoid treating numerical allocations, if one chooses to use numbers, as quantities rather than categories when doing an impact significance rating. And in this regard, it is important to understand that it is mathematically nonsensical to add those numbers to assign impact significance, simply because they denote categories and they are relative rather than absolute quantities. But whichever method you choose to allocate a rating, it's most important that the method of determining significance is clearly explained, it is applied consistently to all the potential impacts, and that it is credible, or in other words, that it is sensible and reflects global best practice. So in the Mitigation Hierarchy Guideline, two approaches to impact significance assessment are described. The first is adherence to thresholds or limits of acceptable change, and the second is the risk-based approach to assessing significance. And I've also just noted here that impacts are broadly regarded as being significant when they have negative effects on valued environmental components, including biodiversity and ecological processes, ecological infrastructure, and related ecosystem services which sustain livelihoods. And here it is important to apply this general measure to direct, indirect, and cumulative impacts. So looking at the formal definitions here of thresholds of concern and limit of acceptable change, the threshold of concern designates the upper and lower limits of acceptability according to particular indicators such as changes in a species extinction risk or in its threat status, loss of areas with an important ecological role including buffers or protected area expansion zones. The limit of acceptable change is the ceiling or maximum change in environmental quality or change to a receptor that can be endured in a particular context. And as impacts move from the lowest thresholds, that is negligible or low concern, through thresholds of concern and of major concern, finally to the limit of acceptable change, their significance increases. So as that final limit of acceptable change approaches, avoidance is the only form of acceptable mitigation. So as the definitions on the previous slide indicate, a key purpose of thresholds of concern and limits of acceptable change is to guide the implementation of the mitigation hierarchy by establishing boundaries beyond which impacts are untenable and must therefore be avoided. So in many instances, these limits may be prescribed in legislation, such as water or air quality objectives, or in guidelines or protocols. But where the thresholds are not made explicit, then the EAP needs to also be guided by the specialists. And importantly, the thresholds and limits provide an early warning sign of a possible fatal flaw where either a predicted impact will be unacceptable and or non-compliant with legislation. And specifically when it comes to biodiversity, both the Mitigation Hierarchy Guideline and the Biodiversity Offset Guideline include tables that then guide the identification of levels of concern with reference to things like critical biodiversity areas, red data lists, Ramsar sites, and so forth. The second method to determining significance is through the risk-based approach that would be familiar to many practitioners. Likelihood is considered a factor of a number of different criteria, including extent, magnitude, or duration, and then likelihood is then combined with consequence to get a risk measure. In applying this approach, it is important to consider the potential for irreplaceable loss of resources. Where there is high uncertainty and a threat of significant environmental impacts, significance ratings should also be increased in line with the precautionary principle. So this slide illustrates a generic risk type table with various risk categories. Now, unfortunately, what we see all too regularly in EIAs is the use of mitigation measures as a kind of magic wand, whereby high or medium significant risks are transformed to low or negligible, when there is no guarantee of the success of the mitigation measure or otherwise a very high degree of uncertainty. So being realistic and objective, as well as cautionary when applying mitigation measures, is essential. And it's not only a question of reducing environmental risk, but also the risks of increased expenses, delays to the project, and of being taken to task by interested and affected parties or commenting authorities. To finish off with, I'll just look a little more closely at this notion of irreplaceable loss, which is also explained in the Draft Mitigation Hierarchy Guideline. For the purposes of the guideline, an irreplaceable loss of resources refers to the loss of a valued environmental component which cannot be replaced or recreated, and for which there are no acceptable, affordable, or accessible substitutes for affected parties. So examples include impacts that contribute to species extinction or loss of a natural or national heritage site, indispensable ecological infrastructure, or when an ecological corridor is at stake that is critical to species survival, evolutionary processes, or climate change adaptation. So just to conclude this session, its purpose has been to unpack the relationship and relevance of the mitigation hierarchy in respect of significance determination. I've emphasized the responsibility of EAPs and their specialist teams to focus on the potential for fatal flaws and residual impacts early on in the planning stages, and then to communicate these explicitly to project developers about the risks involved and where alternatives and lower impact options ought to be sought. I also briefly considered some of the tools and methods used to determine significance, with a reminder that any approach needs to be guided by important principles such as transparency and the precautionary principle which underpins the mitigation hierarchy. So it remains for me to say thank you for listening, and just a reminder that in the next session we'll be focusing on that preventative component of the mitigation hierarchy, comprising avoidance and minimization.